Good morning to all. Today we are going to start our fourth unit, DC machine, transformers and induction motors. From this main topic, we having subdivision topics: construction and principle of operation of DC machines, EMF equation of DC generator, shunt generator, DC motor, speed and torque characteristics of DC series and shunt motors, back EMF, applications of series and shunt motors, single phase and three phase AC systems, phasor notations, single phase transformer and its types, construction and principle of operation of single phase squirrel cage induction motors, construction and operation of stepper and BLDC motor. BLDC means brushless DC motors. Okay, so first topic is construction and principle of operation of DC machines. Okay, so first the DC machines classified into two types. One is DC motor and DC generator. uh, Basically motor, simple definition: motor is an electrical device. It converts electrical power into mechanical power. And DC generator also one of the electrical device. It converts mechanical power into electrical power. A DC motor is an electrical device. It converts electrical power into mechanical power. DC generator is also one of the electrical device. It converts mechanical power into electrical power. Okay, basically electrical machines are classified into main two types. One is AC machine and DC machine. Okay, so in our fourth unit, we having DC machines and AC machines also. Okay, so two machines are together in a fourth unit. So AC machines also classified into motors and generators, but the generator also called as alternator in a AC machine. Okay, so here the first process is construction working. Construction and its working of DC machine is, some parts of machines are there. That parts of machines is shown in the figure. Construction of DC machines. Here frame or yoke. The next part is field winding, soft pole swoosh, field poles, commutator and armature conductor. Only the commutator is present in a DC machines. Okay, so what is the commutator? Commutator also one of the device. It rectifying the AC signal into DC signal. Every rotating machine is producing alternating flux. It's producing alternating flux. But DC generator output is DC supply. How it is convert inside of the machine? We can for that purpose we are using the commutator. Here the commutator is performed in a rectification operation. The rotating part is producing alternating flux. Then the commutator is convert alternating flux into direct flux. Okay, from this construction, the first part is yoke. Yoke, another name is frame. The main function of yoke is mechanical support of the parts. Total mechanical support of the machine is yoke. Okay, then pole and pole source. Pole is one of the component in a DC machine. That poles is um, storing or wounded in some amount of coils. That coil is called field windings. That coil is called field winding. Pole source is maintain the air gap of the rotating part and stationary part. It should maintain the air gap. It's a very important part of pole source. It should it's the distance of the rotating part and stationary part is unequally, means the losses of the machine is greater. Okay, so we want to maintain the distance of the rotating and stationary part is very important. That air gap is common to all the surfaces in 360 degree. Okay, next one, the next field winding. Field winding is the one of the winding in a DC machine. When we can apply the supply voltage of the field winding, only the EMF will be produced. Okay, well, so the principle of machine is basically operated by using Faraday's law of electromagnetic induction principle. Okay, so what is the Faraday's law of electromagnetic induction principle? Explained to us. Whenever the magnetic field is cut a conductor, the EMF will be produced. For example, we take a one conductor. Okay, apply the supply on that conductor. The conductor surroundings some amount of magnetic field is create that conductor in a single conductor. We can wind the n numbers of conductor one on one. Okay, so the punch amount of coils is producing much amount of electrical force. That force is called EMF. Okay, so the automatically the machine is going to rotate. uh, we can receive the mechanical energy. Okay, so here how the DC motor mechanical energy is delivered to the uh, mechanical device. Okay, the soft is transferring the mechanical energy to the mechanical device. uh, Next one is armature core. The armature core is also one of the mechanical parts. It's also occupying some amount of coils, and that coils is called armature windings. Okay, so two windings are there. One is field winding, one other is armature winding. Here the field is a stationary part, armature is a rotating part. Field is a stationary part, armature is a stationary part. Okay, next one, brushes. Mainly DC motor having a brushes. Whenever the rotating machine can get the power supply from the source by using carbon brush. The material of brush is carbon maximum, otherwise it's a uh, graphite. Okay, so that brush is fixed top of the coil by using a spring tension. Okay, uh, this wise the construction of DC machine is explained likewise. Okay, we can see the next class, EMF equation. Thank you.